The telecommunications industry is at a pivotal moment. AI agents are emerging as the dominant architectural pattern for delivering intelligent, autonomous services. But how do we deploy and operate these agents at enterprise scale? In this video, I'll share the Innovations Hub work on building an AI native canvas that addresses three critical questions. How do we expose ODA components as tools for AI agents? How can we deploy agents themselves as components? And perhaps most importantly, how do we operate a multi-vendor, multi-agent architecture at scale while maintaining governance, security, and responsible AI practices? This work has always been part of the Open Digital Architecture Roadmap. The slide I'm showing is several years old and illustrates our strategic evolution, starting with the foundations of a common open API model, building a shared data foundation and creating consistent API integrations across IT services. We then progressed to reusable components running on a standard Canvas platform. The next phase, AI-ready reusable components, was planned before the emergence of generative AI. While we're adopting excellent cross-industry work on artificial intelligence and leveraging powerful foundational Gen AI models, telecommunications bring unique value through domain-specific foundations like intent-based systems. We now have a robust ontology defining the language for interactions between telecom components. By combining best-in-class cross-industry technologies with telco-specific data models, ontologies, and intent languages, we maximize business value for telecommunications operators. The work I'm sharing builds on the Catalyst program and Innovation Hub experiments. Three key catalysts from 2025 significantly influenced our approach. These are the Agent Fabric Catalyst, the Agentic ODA for Personalized Customer Experiences Catalyst, and Growing B2B with Autonomous Agents Catalyst. These catalysts revealed several critical patterns. First, AI agents are clearly emerging as the next architectural paradigm. Modular, task-oriented, context-aware systems that operate autonomously within defined guardrails. Second, Model Context Protocol, or MCP, has become the de facto standard for how agents use APIs as tools. The strong data models and consistent patterns in TM-form open APIs make it relatively straightforward to create MCP wrappers, enabling agents to interact with these APIs using natural language. Third, all these catalysts converge on multi-agent architectures, with modular agents collaborating to deliver target use cases. A consistent finding across industries is that agents work most effectively when tightly scoped. And for broader problems, multiple tightly scoped agents collaborating outperform single general purpose agents. Finally, agents have applicability across every architectural layer. The Agent Fabric Catalyst operates at the resource and service management layers of the ODA, while the other catalysts focus on customer-facing and commercial domains. And agents aren't relevant just on functional domains, but throughout the technology lifecycle from architecture and design through delivery and operations. This raises important questions about how the component and canvas model supports AI agent development. How can we enable MCP as a standard for exposing open APIs as tools within multi-agent architectures? Can we extend the component model to support agentic components? And if so, what additional Canvas services are needed to govern and control a multi-vendor, multi-agent architecture? We must also consider how components Canvas fits within the overall data and AI architecture. So this is my plan for this video, is to consider the MCP. How do we enable MCP as a standard for exposing open APIs as tools? It's to look at multi-agent architecture with many agents and the question of could we extend the component model to enable agentic components? And then it's looking at the additional Canvas services that we could build to govern and control this multi-vendor, multi-agent architecture. And then we're going to ask this question about how does this fit within the overall data and AI architecture? And then I've got 3 smaller topics at the end, which is looking at building a Canvas resource inventory as a registry of components, agents, tools, and use cases, about how we support classical machine learning as well as Gen AI models, and finally about establishing evaluation data and testing frameworks for agentic systems. So the first question is how to build MCP support into ODA components to make them available as tools for AI agents. So this actually has quite a straightforward answer. Our existing component patterns already include declarative model for exposing API services, and components already expose multiple APIs beyond the TM-form functional APIs, supporting cross-industry standard like open metrics and open telemetry. And extending components to expose MCP APIs was as simple as expanding the enumeration to include MCP, which is then consumed by the API operators. Now, MCP requires special handling because it uses an event-based architecture with long-running HTTP connections rather than standard REST-style integration. This means API gateways need special configuration to support these persistent connections. So we've extended the component model to allow the declarative specification of MCP interface types, and we built MCP operators to automatically configure the API gateways for these long-running connections. And we built several MCP servers, including one for the product catalog component. And this slide shows a snippet from that product catalog MCP server implementation. And I'm contrasting this MCP server implementation with the underlying Open API specification. MCP is fundamentally about describing APIs in natural language so agents understand how to use them. And agents need to be able to construct appropriate payloads and interpret the responses. And we built this using Anthropic's open source MCP software development kit. Now, the most important part of this is actually the English description of the API. So we provided detailed descriptions of both the API function and all the arguments. And this contrasts sharply with the Swagger descriptions, which were really designed for API experts, not AI agents. And as part of our work, we conducted extensive experimentation to derive, how do I make sure this language is effective for the agent? One of the things is the arguments do require detailed explanation, and also that the language models work best with examples. We discovered, for example, with the filtering argument, the agent didn't understand how to use filtering when we just had the description on its own, and only when we added specific examples was the agent able to actually follow this and effectively use this filter attribute. So currently we've created custom MCP wrappers for some TM-form open APIs. However, the API workstream has recognized that we could generate these automatically from Swagger files by upgrading the descriptions in Swagger with more detail and with examples, and for them to assume that the Swaggers might be consumed by language models. And ideally, we'll get to a situation where we can automatically generate the MCP services for all open APIs in the future. But as I said, this requires enhancements to the Open API Swagger documentation. But the answer to this first question of how to include MCP as part of this ODA is encouraging, because we've been able to extend the component model to expose MCP servers following all the existing patterns, and it worked seamlessly. The second question concerns embedding agent capabilities inside ODA components. Now, most catalysts deliver multi-agent architectures, so we need the same characteristics we have with composable IT. We need modular, composable AI agents that are easy to deploy, maintain, manage, and upgrade. So let me first outline the assumptions we made when extended the component model to support agents. First, we assumed that foundational Gen AI models and classical machine learning models execute as services accessed through APIs on the underlying cloud platform. We're not embedding language models in agents. Instead, agent software accesses language models through APIs, consistent with most agent frameworks today. Second, CSPs will maintain approved catalogues of foundational GenAI models. And this is standard practice at Vodafone. We have a common platform where any language model must first be on our approved list. And there's a process for adding new models, but we maintain rigorous privacy and security standards. Similarly, we have MLOps processes for approving and deploying classical machine learning models. This falls outside the component scopes. Components access these models through these underlying platforms. The third point is that the agentic components are non-deterministic, requiring significantly more testing. I prefer the term evaluation. Beyond predefined tests, you need comprehensive evaluation datasets and metrics to continuously evaluate agent performance against expectations. And then finally, agent components typically require additional cloud services like vector databases, anonymization services, chunking services. And we need to make these available in the canvas to support AI agents. And so the question is, could we extend the component model to support this, to support and to enable agent components? And the answer is yes. And the extension we've been developing actually originated from one of the catalysts, from the Agentic ODA for Proactive Customer Experiences catalyst. And they propose a sensible approach where components declare which language models they want to access, providing a prioritized list. And the Canvas platform then grants access to whichever subset of those are actually available in the approved language models. And similar to how we previously had exposed APIs and dependent APIs, they propose calling this dependent models. And you describe the models and their priority and provide details about the use case, since we need a use case inventory. And you can also define guardrails. So we don't want unfettered access to these language models with potentially security vulnerabilities. We need guardrails to ensure responsible AI usage. And the data model for declarative requirements allows components to define their guardrails as well, or their thresholds against guardrails as well. And we implemented this experimentally, and we showcased it at DTW earlier this year. And our example used Ava. So that's the TM-Form AI assistant. And we used Ava packaged as a component and deployed on the canvas. And because Ava is now an API first component, we tested integration with this, not through the Ava portal, but by having like a Vodafone internal agent directly communication with Ava through this API. And just a bit of a context, like our internal agent we're using is something which we developed for enterprise architects. So we have something called AI for EA, so AI for enterprise architects. And this provides a suite of sub-agents for enterprise architects to use to perform their role. And this AI for EA was able to directly integrate with Ava through an API. And when the Vodafone enterprise architecture asked a question that might relate to TM-Form standards, the Vodafone agent interacts with the TM-Form agent over the internet using these new standards. And this mechanism, this integration worked really well. And deploying Ava on the canvas provided like immediate reuse of all the existing Canvas services. So we had this modular deployment, we had API exposure to the API gateway, we had observability, we had the identity management, and all these capabilities come standard when you deploy agents as software components. And they are essential requirements for any agent deployment. But we've extended this with definitions for these declarative requirements for GenAI models. And this shows how this works. And using Ava as the example component. So the component includes a specification, and we created a new AI operator that reads these declarative requirements, and our reference implementation shows the source code for this example reference operator. And this operator configures a new architectural element. So to grant access to foundational GenAI models, we've introduced an AI gateway. And when granting access to underlying models, it's providing through this gateway, or could call it a proxy. And this enables auditing of all the interactions, which is essential for responsible AI practices. It provides observability into exactly what's being discussed between the components, the agents, and the underlying language models. And it also enables us to understand the cost. So how many tokens of which model a component is consuming, feeding into our cost management operator. And the process follows 4 steps. So an operator reads the declarative requirements, configures the AI gateway, grants the component access with authentication and endpoint details for accessing the language models, and it enforces the guardrails while providing this data for auditing, observability, and cost management. And this forms the foundation for what the Canvas must provide to support multi-vendor AI agents across every functional domain, enabling the governance and control and responsible AI adoption at scale. So I'm now looking at it from the other perspective. So from Canvas services, what Canvas services do I need for this multi-vendor AI agents across every functional domain? So what we need is, clearly we need the language models, we need other AI models like embedding models, multimodal models, and even supporting classical machine learning models with like a corresponding ML ops processes. We need the Canvas to have these additional capabilities like vector databases, anonymization, chunking, and other cloud services. The observability extends beyond the technical monitoring and performance of standard software to include AI-specific observability for language models, supporting tools like Langsmith or Open LLM Telemetry, which is an Open Telemetry extension. Like we're proposing this AI gateway as a standard architectural component, enabling automated guardrails, auditing, and cost control. We're also addressing how to support evaluation, so pre-production and post-production evaluation of ongoing AI performance, and I'll come on to that a little later. Finally, the Canvas includes a use case registry with tagging of all agents, tools, and high-risk use cases, which is a requirement for this EU AI Act. So how does this fit into the end-to-end AI and data architecture? We've been collaborating between the composable IT mission, where the Canvas and component work resides, and the AI and data mission. So we need one end-to-end open digital architecture supporting everything. And the good news is the data and AI architecture is embracing this Canvas concept as well. So the Canvas operating like an operating system for running software, including AI. And I've got 2 slides which illustrate this evolution to support AI services. So historically, we worked on composable IT within ODA, so modular standard components. Extensive work building these components with use cases, understanding high-value scenarios, and catalyst programs, experimenting with different case studies. The standard components are consumed by the ODA Canvas, and operators in the ODA Canvas read the component requirements and configure underlying foundational cloud platform services like API gateways, service meshes, observability, identity, and access management systems. Now, the second slide is a build which then shows the AI native Canvas extensions. Now, alongside standard ODA components, we have Agentic components embedding AI agents. Components can offer MCP, so they're available as tools towards other agents. And this supports emerging standards like A2A or agent from Google, where an agent component exposes the equivalent of a business card or an agent card, explaining their capabilities as part of a YAML contract, which we're including as part of the component specification. So I can have systems of record ODA component exposing MCP interface so it's available towards an agent, and I can have an agent deployed as a component, and this agent will expose an A2A interface so other agent can discover its capabilities and the services it offers. These agentic components have corresponding operators. For example, there's a model operator which takes the declarative requirements and configures the AI gateway to grant access to the underlying language models for agentic components. So the patterns we've already established fit naturally with these AI services. And in the experimentation, we've successfully extended the ODA component model for agentic components. We've intentionally coloured the ODA components white. This contrasts with the systems of record components. These are the components maintaining the fundamental data that you need to drive telco architecture. For engagement management, we decided at the outset not to build standardized components. Most telcos build custom software deployable as components in Canvas environments, but we don't standardize the engagement management because we want unique, innovative experiences, like a Vodafone specific experience that we're building internally. For the underlying systems of record, we do want standardization. But with agents, at least in 2025, we decided at this moment in time, we don't want to standardize our agents. And that's why we colored it in white. We're saying we want to deploy agents as components following the component model. We're not yet positioning them to be standardized agents. And this is similar to the engagement management. We have non-standard agents that can seamlessly interact and interrogate all the systems of record components, leveraging the foundational data within the TM-Form standards. And so this represents the end-to-end architectures, including composable components and extended to composable agent components with corresponding AI native Canvas services. And this allows AI and the data foundations while extending the standards we've been building as part of this ODA. And we plan to extend this with data products as a service, enabling organizations to offer data products. Components will declare requirements for data products, with data operators integrating and granting access through these underlying data services. So this is the end-to-end architecture, including Agentic ODA. Now I'm going to come on to 3 subtopics. This is the main scope of the presentation. I've got 3 subtopics. So the first one is this notion of having a Canvas resource inventory as a registry of components, agents, tools, and use cases. And this is a practical example of what it means. So on top of the Canvas, we built a resource inventory. We built components and exposed APIs and other services into the Canvas, and it makes it straightforward to put these into a TM-Form compliant resource inventory, serving as a registry of components, agents, tools, and use cases. And as with all the TM-Form APIs, these can be also exposed as an MCP server, make it available to AI agents. So the Canvas itself includes ODA with this resource inventory of components and corresponding elements like APIs, dependent APIs, and similar resources. And we've used this TMF 639 resource inventory as a standard interface. And I've got a practical example of using Claude Desktop as an external AI agent. So this Claude Desktop can integrate to the Canvas using the MCP server as a tool. So the Canvas can appear as a tool. And then you can ask questions in natural language. So I can ask questions like, what resources are available in the ODA Canvas? So this queries a live Canvas implementation where I really deployed these components. And you can see that when I ask this question, it's calling this MCP resource get service to get details of resources, and then it's answering in natural language. So you can see I've deployed this R1 product catalog management ODA component, and it's exposing certain APIs, including my metric service, some product catalog management, and the MCP service. And I can ask a more detailed question. So I asked, describe the product catalog management API in detail. And she's doing another call into the MCP server to get even more detail. And then you get a detailed description. And finally, because these agents can actually also create diagrams, so I've asked it to create a diagram of the product catalog component and all related resources. And you see it's done a really nice job of, this is the product catalog management component, and it's exposing all these underlying APIs. It's even linking to say, this is the TMF specification that API uses, and it has other details like who maintains this component and other things. And this was automatically generated just by using an AI agent with the ability to create diagrams by interrogating the Canvas using MCP. My next subpoint is this notion of supporting classical machine learning models as well as Gen AI models. We had a proposal, and we had a very similar proposal from Vodafone Greece and from Huawei for an AI model manager for custom machine learning models. For custom machine learning models, the component needs to include that custom model as part of that component definition. So in a similar way to how we have container images in a Kubernetes manifest, we're adopting the same approach. So the component would include a URL to a machine learning model in some accessible model repository. And the model manager operator would download this model and submit it into an MLOps pipeline for review, testing, and deployment. And then once it's been reviewed and approved and deployed, the canvas then provides API access to the inference engine so the component can access that custom model. And then the very final point is the importance of evaluation data and tests. Because these AI services are non-deterministic, components should come packaged with complete evaluation data sets and tests. And pre-deployment, we conduct a comprehensive evaluation, establish baseline performance for the agent, and then even in production, we want to continuously evaluate and monitor agent behavior and characteristics. And this is something we've implemented with our AVA example agentic component. So for AVA, we started the project. Our aspiration was to have 100 questions. I think we ran out after something like 87 questions, representing the types of questions someone might ask the TM-Form AI assistant. So this forms like our golden set of evaluation questions. And during real usage, we log user questions, gathering information about what people are actually asking AVA. And we also log the AVA responses. So we're creating evaluation questions with AVA responses, which allows us to do automatic and human-based manual evaluation. So in production at scale, you want to be able to use AI-based evaluators to evaluate AVA's performance and the responses. And alongside that, we provide the ability for humans to evaluate the capability. And we've built an interface for human evaluation. And that's used for feedback to refine AVA and to test, for example, when we change the underlying foundation model underpinning AVA, we'd repeat the evaluation before deploying that new model into production. So this is showing the human evaluation user interface. So you can see this is the evaluation question. It's one of our golden questions. It's asking about Eton business activities. And this is showing the logged answer from AVA. So as the human evaluator, you get to score it for relevance, accuracy, completeness, and give some commentary on why you've given it a particular score. We have something very similar. So we have, for agent evaluation, we're using the LangGraph open sourced evaluation framework. And then this uses like a prompt template for evaluating it. You're saying you're an expert evaluator, and it gives the question and the answer, and is asking the AI, so separate AI model, to evaluate the answer to the question for relevance, accuracy, completeness, and given overall assessments. You get a very similar evaluation from the AI agent, and that allows us to then have like good metrics about the evaluation, where we can see, was this like an evaluation, like a golden question, or was this a user question, and was this manually evaluated or using the automatic AI evaluation? And finally, that gives us this ability to have like a dashboard where I can monitor the performance of this agent over time and ensure that we're constantly evaluating the performance, and then whenever we're making a new change, we're ensuring that that change improves the overall performance. So that's the introduction to the AI native canvas and the concept of supporting agentic components, components that embed AI agents while exposing their capabilities as tools towards other agents, enabling this multi-agent architecture operating at scale. And what makes this approach powerful is that it provides the governance and control CSP needs. We can operate these systems at scale while absolutely implementing responsible AI practices with the auditing, observability, cost control, and continuous evaluation required for production enterprise systems. And this work demonstrates that the open digital architecture isn't just ready for AI, it's architected to make AI operationally viable at telecommunication scale. The Canvas provides the foundation for CSPs to confidently deploy and operate multi-vendor agent architectures across every functional domain, with the governance frameworks demanded by both regulators and responsible enterprise practices. Thank you for your time.